This video we're going to look at the solution methods for linear first order difference equations, and we're going to start with a fairly simple example. It's a non-homogeneous equation with a constant term on the right hand side. Now, to solve equations of this type, the solution method is very similar to that for differential equations. It's the sum of the complementary function, which is the solution of the associated homogeneous equation, and a particular integral. Now, the complementary function is very easy for a linear equation. We've got yc equals a constant c multiplied by minus 1 over 5 to the power n. The particular integral is solved for by assuming that y is constant, so we have yp equals minus 1/5 yp plus 10, which solves to give us 6 over 5 yp equals 10, yp equals 50 over 6, or simplifying 25 over 3. So we can write down the general solution of the non-homogeneous equation as the sum of these two solutions. It's c multiplied by minus 1/5 n plus 25 over 3. Now we use the initial condition to eliminate the constant of integration. So we have 1 equals c plus 25 over 3, or c is equal to minus 22 over 3. So the particular solution for this problem is given by yn equals minus 22 over 3 multiplied by minus 1/5 to the power n plus 25 over 3. That was relatively easy because of the nature of the non-homogeneous part. We'll now look at a more complicated example in which the non-homogeneous part is itself a function of n. Here we need to use the method of undetermined coefficients to solve for the particular integral. So our solution, as before, is the sum of the complementary function and a particular integral. The complementary function is very easy. We've simply got yc equals c multiplied by a quarter to the power n. Now, for the particular integral, we assume a function of the form a e to the power bn, and then we look for values of capital A and B which satisfy our equation. So, substituting in, we have a e to the power bn is equal to a quarter a e to the power b multiplied by n minus 1 plus e to the power minus a half n. There's only one value of b which will satisfy this equation, and that's b is equal to minus a half. So we can substitute that in straight away. And we can write it as a e to the power minus a half n is equal to a quarter a e to the power minus a half n multiplied by e to the power a half plus e to the minus a half multiplied by n. And we can immediately cancel the e to the minus a half n and write this as a is equal to a quarter multiplied by a times e to the power a half plus 1. We can now solve for a quite straightforwardly, and we'll get a is equal to 4 divided by 4 minus e to the power a half. Now, that will allow us to write our general solution for this equation as yn is equal to c multiplied by a quarter to the power n plus 4 over 4 minus e to the power a half multiplied by e to the minus a half to the power n.